Okay, so I hope you all are ready and we can start the session for the day. Any confirmations? Am I audible?
Yes, ma'am.
Yeah.
Yes, ma'am.
Thank you. Thank you. Okay, so I am going to share my screen. Give me a second. So I think today is the day 4, and I am going to discuss one sample t-test, right? Okay. And for the same, I have also shared the sheet on the group, on the WhatsApp group. I hope people have received. I think I shared my screen. I want your confirmation whether it is visible or not.
Yes, ma'am.
Yeah, fine. May I know the name? Who is very prompt?
Ma'am Sonika.
Sonika, ma'am. Thank you so much, ma'am. Okay, fine. So I think if I want to summarize till day today that what we have seen till now. So I think at the first day I tried to explain you the basics of the research, and then I talked about the SPSS, right? Then we have seen how to define a variable, what are the rules which can help us to define a variable. Then I tried to explain you that how to import the data in SPSS. This was the day 1. After that, I have explained you reliability and the normality concept. We have seen conceptually, and also after that, I tried to explain you both the things, that how we can check these two things, these two concepts using the SPSS, right? Yesterday, I think I discussed the non-parametric test, that is the chi-square test. Today is the day 4, and I am starting with the parametric test, right? So agenda is today I'm going to discuss one sample t-test, but before talking about one sample t-test, I want to ask the friends, those who are listening to me, that can anyone of you tell me what do you understand by term parametric test? I think anyone can unmute and can share. Yes. Am I audible, friends, or not?
Yes, ma'am.
Yeah.
Yes, ma'am.
Audible.
Yeah.
Audible.
Fine. Thank you. Thank you. So, can anyone tell me what do you understand by term parametric test? Fine. Okay, yesterday I discussed the non-parametric test. So can anyone tell me that what you have understood by the term non-parametric test yesterday?
Ma'am, good evening.
Good evening.
Non-parametric test, you specified two conditions that they are used when the data distribution is not normal or it is skewed or kurtotic, and the data variables are categorical in nature.
Yes,
These are the
very good. Thank you. May I know the name, ma'am?
Ma'am Ritika.
Ritika, ma'am. Very correct. Ritika, ma'am said very correctly. Yesterday, I think in a brief manner, I said this thing, that when we are having the categorical variables, that is the prior condition for the non-parametric test. And second condition is when we are not bothering about the normal distribution of the data. Means it might be possible we are having the data on Likert scale, that on the numerical scale or on the continuous scale, right? And we are now looking for the normal distribution, because generally when we are having the continuous data or numeric data, we are generally suggested to check the normality of the data. But in many cases, it happens that the data is violating such kind of assumptions. So in that case, we can move to the non-parametric tests. So non-parametric tests are the tests which are distribution free, and also these tests do not consider the parameters of the population. Parameters means as I have shown you yesterday, the formula of the chi-square test. We have seen this thing that generally in case of chi-square test, we are talking about the frequencies. So frequencies are not the parameter. Parameter will be characteristics or the features of the population. So I can say mean, or I can say the variance or standard deviation, proportion, etc. can be the parameters or characteristics of the population. So if we are considering those things, in that case we are going for the parametric test. But if we are not considering those things, we are going for the non-parametric test, right? So today when I want to define the parametric test, I can say this thing, that parametric tests are the tests which are based on the normal distribution, or in easier manner you can say this thing. Generally we are means we can say we are having the continuous data, we are having the numeric data, and then we need to use to test the normality assumption for the data, and these tests are based on the parameters of the population. So I think those who are good in statistics or maybe performed the various statistical tools or tests manually, so they maybe noted this thing that when we talk about the formulae of like t-test, z-test, ANOVA, etc., so there we are talking about the things like mean, standard deviation, etc. So when we are talking about these things, means we are talking about the parameters of the population. So in that case, we are talking about that we need to apply the parametric test on the data, and that way you need to generally test the assumption, right? So, in the upcoming slides, we will discuss that what are the various assumptions generally. Usually assumptions may vary from test to test, right? But in many cases, some of the assumptions are common, right? So I hope the meaning of parametric and non-parametric is clear to everyone now. Is it fine? May I proceed?
Yes, ma'am.
Yeah.
Yes, ma'am.
Yeah. So I'll come now on the one sample t-test here. Generally, when I say one sample t-test, it is nothing but it is a parametric test, right? Because if you see the formula of the t-test, generally it is based on the parameters, like I can say it's x bar minus mu divided by sigma divided by root n. That is the actual formula. Using that, we can calculate the value of one sample t-test, right? So that means in t-test, we can say we are considering the parameters of the population. That's why it is a parametric test, right? So generally, this one sample t-test will help us to determine whether the sample mean is statistically different from a known or hypothesized population mean. Or in easy manner, if I want to explain you point number 2, I can say this thing. In case of one sample t-test, we are comparing the sample mean and the population mean, or maybe the hypothesized mean, which we are hypothesizing that this can be the mean of the population, right? So that way, this is the main purpose of the one sample t-test, right? Here, whenever we are talking about one sample t-test, so whatever variable we are testing, it is generally termed as the test variable, right? So for this test variable, we need to have the test value, right? So we will provide the test value again for the test variable. We need to provide the test value, right? And this test value is nothing. It is either the hypothesized value, means which you are assuming by your own, or maybe it will be the known value to you, right? So generally, again, I will say this thing. Those who are having the background of the statistics, maybe they are knowing this thing that there is two tests, that is the Z test and the T test, right? And generally, usually people are saying that when the sample size is less than 30, we need to go for the T test. When the sample size is greater than 30, we need to go for the Z test. Apart from this bifurcation, there is one more important thing, is that when you are not knowing the standard deviation of the population, in that case you need to go for the t-test. And I think in many cases it is possible, even we are not knowing our complete population also, right? So in that case, that means we are not knowing the standard deviation of the population, so rather than applying the Z test, we are applying the t-test. So this is the important condition, that why we are applying t-test in comparison to the Z test. Further, these are the manual procedures which we usually follow in case of one sample t-test. Generally, you need to define your null hypothesis. You need to define your alternative hypothesis. I think I do not need to comment on null and alternative. You people are knowing. Generally, when we are saying no difference or no relationship is existing type of thing, that is generally treated as a null hypothesis. Null means nothing, void, right? When we are saying something is existing between the two variables, some relationship or maybe impact type of thing is there, so that will become your alternative hypothesis. So firstly, you need to quote your null and then alternative hypothesis. Then you have to decide upon the alpha value. May I know what do you mean by the term alpha in case of the hypothesis testing? Anyone? What is alpha? I hope you people are listening to me.
Yes, ma'am, listening.
Yeah. So may I know any from any one of you that what do you mean by alpha in context to the hypothesis?
Ma'am, alpha is level of significance.
Very correct. Alpha is nothing but it is a level of significance. Means the risk percent you are mentioning that it can be the 5%. Usually, in most of the researches we are using 5%. Generally, this percent varies from the discipline to discipline. In medical field, we cannot take the higher risk because generally in medical sciences we are talking about the life, right, or that type of thing. So generally that percent will be little lower, but usually in social sciences, I belong to social science because I am from the management side. So generally in behavioral sciences, management sciences, we social sciences, we can keep this percent as 5%, or else you can go for the 10% also, or 1% also, 0.1% also, up to you, right? But in most of the cases alpha value is generally 5%, right? So 5% level, 5% is the level of significance, or you can say it is the risk capability. You can say at 5% is the chances of committing type 1 error, right? So that is the alpha. Further, you need to talk about the degrees of freedom. So in case of t-test, you need to know the degrees of freedom. Generally, it is n minus 1. So that is what is the sample size. That minus 1 become your degrees of freedom. Then you need to know the decision rule. Decision rule is the thumb rule generally. I think yesterday I told you in case of the p-value. So the thumb rule says if your p-value is less than your level of significance, in that case, you are going to reject your null hypothesis, and vice versa. That means when your p-value is greater than your level of significance, you need to accept your null hypothesis, right? Then you need to calculate the test statistics. So here in case of t, you can see this is the formula. Using that, you can calculate the value of t. You can state your results. You can make your conclusions, right? So this will be the normal procedure which you need to follow generally. So I think till here, from point number 1, that is from defining of the hypothesis till state decision rule, this is the thing you need to do by your own. Further, using your particular software, you can calculate the values, and then you can state the results, and you can make your conclusion, right? Further, talking about that, if I go for the manual thing, so in case of manual processes, always you need to compare your calculated value of the statistics with the table value. So I think yesterday I talked about the chi-square test. There also I have shown you the table. Here also in case of t-test, this is the table. Using this table, you can get the table value of the t, and then you can make comparison of in between calculated and tabulated value, right? So you can see generally you need to have two things. First one is the degrees of freedom. That is, you can see here, which is the first column, most left column I'm talking about. So in this column, you can locate your degrees of freedom, and then according to your level of significance, that is alpha value, you can take the alpha values from here, and in the intersection of these two, you can locate the value of your t, and that you can compare with your calculated value, and then you can make your decision, right? Now talking about when I say one sample t-test, so generally there can be three types of hypothesis possibilities there. The first one says here it says mu is equals to x bar, and second says mu is not equals to x bar, right? So mu is what? Mu is your population mean, and x bar is your sample mean, and you are saying this thing that population mean is equals to your sample mean, right? Alternatively, you are saying that population mean is not equals to the sample mean. That means here you can see I have mentioned the tails. So in case of the first case, number of tails will be 2. That means you can say why I have said this thing, because I am stating in the alternative hypothesis, I am stating mu is not equals to x bar. So meaning is what? Mu can be either greater than or mu can be either less than. Means both the possibilities are existing here. So that way you can call it as a two tails are involved here, right? But when you are clearly mentioning that whether your mu is less than or greater than to the sample mean, that means here in the null you are saying mu is greater than and equals to x bar, means your population mean is greater than or equals to your sample mean. Alternatively, you are saying that population mean is less than your sample mean. So when you are clearly stating the side, whether the x and mu are greater than and less than, in that case this is a clear case and we can call it as a one-tailed involved here, right? So this way, first one is the two-tailed hypothesis formulation, and now remaining two are the one-tailed hypothesis formulation, right? So when you talk about, just a minute, I need to shift it. Yeah. So when I talk about two-tailed test, right? So in case of two-tailed test, the rejection reason of your null hypothesis falls on both the tails, right? And the middle area which you can find, which you can see, which is in the white color, this is the acceptance reason of your null hypothesis. Do not reject. Null means you need to accept your null if your value is falling in between this, means in this, coming in this particular reason. But if your value is falling in this reason, in that case you are going to reject your null hypothesis, right? So this is a case of two-tailed test. Similarly, if I talk about the one-tailed test, so in case of one-tailed test, your rejection reason will fall on the tails, right? So in either of the tails. So in this case, you can see for the left-tailed test, your rejection reason will fall on the left tail, and the entire remaining reason will become the acceptance reason for your null hypothesis. Similarly, in case of right-tailed test, the rejection reason will fall at the right tail, and the remaining reason will become the acceptance reason for your null hypothesis. So this way, these all things, generally these are the conceptual things I think I tried to explain you. Although it may take time, maybe when we can meet or somewhere, miss, it is like in the physical interaction it is quite possible to make you these things more clear, but I hope I tried a lot to explain you these things here. So this way you can understand this is the conceptual background of your hypothesis and the acceptance and rejection reason of your hypothesis, right? Always we are testing the null hypothesis, means whatever test we are applying on the null hypothesis, and then we are saying this thing whether we are accepting or rejecting the null hypothesis. And always if you are accepting the null hypothesis, that means it is by default you are not going with the alternative hypothesis, and if you are rejecting the null hypothesis, that means you are going to accept your alternative hypothesis, right? So that means this is the way of understanding the one-tailed and two-tailed test in case of one sample t-test. I think these are the word or the statement formulation of the hypothesis, which I already told you. This is the first case when you are saying that there is no significant difference in the sample mean and the population mean. So when you are saying there is no significant difference, right? So that way it is clear that you are talking about the two-tailed test. Means alternatively you will say there is a significant difference. So when you are saying there is a significant difference, that means the difference is existing, but that difference is greater than and less than. You are not mentioning that. That will be the case of two-tailed test, right? But when you are clearly saying that sample mean is significantly less than or equal to population mean or something like that, that means that is a case of one-tailed test, right? So this way you can write the hypothesis in the text form or in the word form. Further, talking about the assumptions of the t-test, the first assumption says the dependent variable must be continuous. That means your variable should be numeric variable. It can be the interval scale variable or the ratio scale variable, right? So the dependent variable must be continuous in nature. Second is, I think I'm not reading this. This is, I think, quite clear that continuous variable means it can be interval or ratio. It should not be the categorical variable, right? Further, I think normal distribution, I will take it afterward. I think it will be there in the coming slides. Yes. Second point says the observations are independent of one another. So again, I will repeat the sentence which I said yesterday. When you are saying this thing, observations are independent, meaning is that you need to collect the data from one person only once. That way, it is quite obvious that observations will be independent. It is not like to meet your sample size obligations or something like that. You are taking the responses from the same person twice or thrice or more than that also. So it is not acceptable. In that way, this assumption will be violated. So only once you need to collect the data from a particular respondent, right? And then one more thing, that the process should be random, that is without replacement. Random meaning is it is not like you are pre-deciding that I will go to this person and ask the particular thing. So randomly you need to select your respondents. Next is the dependent variables should be approximately normally distributed. I think if you can recall the session which I delivered on the day 2, there I said usually in the practical life or in the real world, it is not possible to have a exact normally distributed data we are having. In that case, we need to do little bit compromise with the normality, and that is why you can say I have mentioned here approximately normally distributed, not exactly, right? So that way you need to see this thing, your dependent variable. And if you can recall in the previous slide, I said dependent variable will be generally continuous in nature. And always you need to check the normality of the continuous variable. For categorical variable, generally there is no meaning of checking the normality, right? And how you can check? So I think methods I have already discussed in the second session. Talking about the next assumption, the assumption says that that the dependent variable should not contain any outliers. So you need to see this thing that there should be no outliers available in your variable, right? So using box plot, that you can identify, or you can say this thing, check this thing that whether the outlier is available or not, right? So these are the assumptions. Further, I think if this type of histogram, because one of the methods of checking the normality is the histogram, I have already communicated this thing to all of you. So if your data is showing this type of graphical representation of the data, in that case you can say somewhere that your data is approximately normally distributed. Now using the box plot, as I said, you can identify the outliers in your data. And if you can recall the session, you can see this thing. Generally outliers will coming beyond the whiskers. Whiskers, I think I've told you, these tails are known as the whiskers. This is upper whisker, this is lower whisker, right? And if any of the data points are falling beyond the whiskers, maybe the upper whisker or maybe the lower whisker, in that case these are treated as an outliers, right? SPSS provides us the facility to identify significant and insignificant outliers. Generally, circles are treated as the insignificant outliers. That means if they are presenting, they are not that much impacting your results, right? Significant outliers will be generally represented by the asterisk sign in SPSS. And that means if the asterisk sign is coming in the box plot, that means it is an indication that this is the significant outlier and this can impact your results fiercely, right? So you need to take a what I can say caution, or you need to see whether you can discard that, or if you are keeping, so while you're keeping you need to give the justification, right? So I think these are the graphs which are explaining you whether your data is symmetric, positively skewed data, negatively skewed data, or what is this status of the tails of your data. So looking at these different graphs, that we can identify whether the data is symmetric, skewed, or positively or negatively skewed, or whether the tails are fatter or they are the thinner. That way you need to understand this thing, and this way using the graphical representation, again we can ascertain the normality of the data or variable. Now, how to apply the one sample t-test in SPSS? I think this is the process, but I think I will not go in this. I'll now directly come to the that file of SPSS. I think I shared with all of you. I hope you got it. Anyone?
Yes, ma'am.
Yeah. So I'm expecting you to please open it. I need to also open because I think due to my meeting, I haven't prepared anything. Yeah. So I opened it. Give me a second. Okay. I think you can see my SPSS file. It is visible to everyone.
Yes, ma'am.
Yes, ma'am.
Yes, thank you so much for the confirmation. Now you can see in this particular file, there are few variables. Give me a second. I need to plug in for the charging of my laptop. Give me a second. Yes. So you can see there are two variables. One is a score, second one is IQ. I'll go to the variable view. You can see these are the numeric variables listed here, and these are the measurement skills. So that is, you can find here if you want to make the changes in the name of the variable, you are free to do that using your keyboard. You can make changes. If you want to make changes in other parameters also of the variable characteristics, that you can make in the variable. If all is fine, you can come back to your data view. I hope it is clear. May I proceed now?
Yes, ma'am.
Yeah. Yeah. So now what we will do, firstly, we will check the assumptions and then we will apply the one sample t-test in SPSS, right? So I think there are two variables available. And if you can recall the conceptual explanation by me for the one sample t-test, can anyone tell me how many variables are required to perform one sample t-test? Yes.
Only one variable.
Okay. May I know the name, sir?
Vijay Kumar.
Very correct. Very good, sir. We need to, from name itself, it is very clear. It's one sample t-test. That means we need to have only one variable. So two variables I have given. On one, I will perform the analysis, and on second, you can perform the analysis, right? So this is for the practice purpose. So suppose I'm opting for a score variable. Is it fine, or I need to go for IQ? As you say, accordingly, I'll take. Which variable I need to opt for?
IQ, ma'am.
IQ, fine. So I'm opting for the IQ variable, right? So firstly, you need to check the first assumption. Okay, just me, I'll toggle between the slides. I'll come to the assumption part. Yeah, one by one we will move, right? First assumption says the dependent variable must be continuous. So as we will be having a single variable, that variable we can treat as a dependent variable, right? Now you need to see the IQ variable is continuous in nature or not. So can anyone tell me it is continuous or not? Yes? Anyone?
It is discrete in nature.
Okay, so it is like it cannot be continuous. It is something.
If we can fix up some values between which we can say that it lies, then we can say it may be continuous.
Okay. I think IQ is the ratio of the mental age and the physical age or something like that. I think this is the formula, right? So it is not like I have taken these figures in the whole number, but it can be like IQ can also be in the decimal point also. So you need to see the nature of the variable. IQ can accept the values in the decimal points also. That means it is a continuous variable. Although all the values listed here are the discrete in nature, whole number. Fine, sir, Vivek, sir.
Yes, ma'am.
Right?
Yeah.
So that way you can see this thing that your variable can accept that thing or not. If suppose I am saying number of families, so number of families can never be in the decimal points. It is quite obvious. I can say 10 family, 15 family, but I cannot say 12.5 families. So the nature of variable it cannot accept, or if it is accepting means you are writing, there is no meaning of writing that, right? So I can say IQ can be a continuous scale variable. It can be defined in terms of the decimal points also. Right, so there will be some meaning of that value. So that way you can say that IQ is the continuous scale variable. We can treat this variable as a dependent variable. Till here it is okay, fine, clear?
Yes, ma'am.
Okay, ma'am.
Yeah. Second assumption says you need to check observations are independent of one another or not. So I think I am assuming, because I given you this data, so I am assuming this thing that for each and every person I have calculated the IQ only once. Right? So it is not like I have calculated IQ of one person twice or thrice. It is not like that. For every person, I have only calculated his IQ value only once. So that way, independency can be maintained here. Okay, fine. May I proceed for the next? It is okay? Fine?
Yeah.
Yeah. Next is the dependent variable should be approximately normally distributed. So now dependent normality and the outliers both we are checking together. And can anyone tell me how we can do that? Yesterday, no, day before yesterday, I think I discussed the checking of the normality. So can anyone tell me how we can do that? Yes.
मीन के माध्यम से मैडम इसको नॉर्मलिटी चेक की जा सकती है.
Okay, fine. That is the one way. Other way, sir?
Ma'am, we can check skewness or kurtosis values, the range, and if it falls for a normal distribution or not.
Very good. So I think few methods you tell. Now you can tell me in SPSS how can I perform these things? Anyone?
Ma'am,
Analyze.
Analyze. Fine. Good. Then
ma'am said
Descriptive statistics.
descriptive statistics. Very good. Then
Next, explore.
explore. Very correct. Very good. So we will go to the analyze. We'll go to the descriptive statistics and then we'll go to the explore. So I think it's very commendable. Many of you are giving answers. So I'm feeling a little satisfactory that people are noting down or maybe practicing along with me. So it's great. I'm clicking on the explore now. You can see once I have clicked on the explore, this box is coming. All the variables of the data sheet is listed in the left box. Now I need to select your variable. My variable was IQ. I think ma'am said I need to go for the IQ. So I'm selecting the IQ and shifting it to the dependent list box. Till here, I think it is fine. Those who are performing, they did this. May I proceed?
yes, ma'am.
Yeah. Now you need to click on the descriptives and in statistics, and there you can find descriptives is already selected. This is the by default selection by the SPSS. And and also we need to get this. So we will go with the
Continue.
yes. Next we go for the plots.
Plots.
Very good. So here factor box plot is showing factor levels together. Factor levels together meaning factor is generally the independent variable. And in independent variable, if there are labels, so in a single box, you will get the box plot for both the labels. This is the meaning. So this is by default option, but you can see we are not taking anything in the factor list, right? So there is no meaning in doing any of the thing. Whatever is by default, we'll go with this. Deselect.
Unselect, madam.
Sorry.
Select histogram.
Yes, select histogram. Very correct. And lastly, we need to check normality
Normality.
plots with test. Very correct. I think it's Sonika ma'am.
Shanti.
Shanti ma'am. Very correct. Very good ma'am. So we are now going with these particular selections. I hope everyone has marked them. May I proceed with the continue button?
Yes, ma'am.
After continuing button, you will be back and then you are all prepared to generate your outputs. So you need to only click on the OK button, right? So I hope you can see my screen of the output window.
Yes, ma'am.
Yeah. So here I'll explain you from the first table. Although I think we have already seen explanation of these previously also, but again I'm explaining you this. This is the case processing summary where you can find we are having total 80 people of the so 80% IQ values available. That means sample size is 40. Sorry, not 80, it's 40. So the sample size is 40. No missing value. Total is 40. Coming to the next table, which is the descriptives table for the IQ. So the mean IQ is 109.45. 95% confidence interval for mean. This range says this range is 107.73 to 111.17. 5% trimmed meaning is that you are removing 5% of the outliers from both the sides, upper and lower, and that way you are getting your trimmed mean value. You can compare these two. These are very near to each other. So it might be possible your variable can be, say this thing that it can be the normally distributed variable, right? Because median you can also find median and mean values are not very far from each other, right? Variance is 28.81. Standard deviation is 5.368. Minimum of the IQ is 99 and highest value of the IQ is 121. Range is difference of these two, which is 22. Interquartile range is the difference of third quartile and the first quartile, which is coming as 9. Skewness and kurtosis values you can find both are negative. Negative meaning is skewness is, if skewness is negative, that means your data or your variable is negatively skewed, right? For kurtosis, if it is negative, your IQ variable is platykurtic. This is the meaning. But as I said, in the real world, we will not get exactly the values which are requiring for skewness and kurtosis. For skewness, we need to have 0 value. For curtosis, we need to have 3. But I think on the day 2, I have given you the threshold values. So threshold range for skewness was -2 to +2. So if you are writing -2 to +2, you can see this -0.38 is coming in that range. Similarly, kurtosis is also coming in the range, that is -3 to +3. So that way, somewhere you can say that your IQ variable is approximately normally distributed. To ascertain this, you will go to the next table, that is the test of the normality. Here you can see the Shapiro-Wilks test. Generally, for the small sample size, we are looking for the Shapiro-Wilks. You can see the significant value is coming as 0.684. So I think before interpreting this, can anyone can recall what will be the hypothesis for the Shapiro-Wilks? Anyone? Anyone? I hope you are listening to me. I think it is little tough to understand in the online platforms. I hope you people are with me.
Here, ma'am,
जी
true
मैडम जी
significance means
Sorry, I'm not getting you.
I ma'am,
No,
I think true significance means
no,
alternative hypothesis. Lower bound of the true significance means null hypothesis.
no. For the Shapiro-Wilks test, I think they before yesterday I told you the hypothesis and I told you people to note it down. I don't know if people have noted or not. Okay, again I'm repeating because in upcoming days also we need to check the normality. So I will check you in the later classes, maybe tomorrow and day after tomorrow. I'll ask you what is the hypothesis for the normality, right? So here, if you have not noted down, you please note down in your notebooks that the hypothesis for the Shapiro-Wilks is variable is normally distributed. Fine.
Okay, ma'am.
Yeah. Now we can interpret the results. Significant value is 0.684 and level of significance is 5%, right? So 5% meaning is 0.05. So you need to compare 0.684 from 0.05. So what you will conclude? Yes. What will you conclude?
Since the value is greater than 0.05, the null is accepted.
Very correct. As the p-value is greater than 0.05 or the level of your significance, you are going to accept your null hypothesis, and your null hypothesis says that their variable is normally distributed. Variable means IQ is normally distributed. So we can come to the conclusion that the IQ is normally distributed. Coming to the histogram, although I think data is only 40 in size, so you can see histogram is not that much proper. So if you want, you can skip this, right? Come down, looking at the QQ plot. As you can see, this is the fitted line, and all the data points are almost very near to a fitted line. So that means your variable is approximately normally distributed according to the QQ plot also. Going down, looking at the box plot is helping us to identify the outliers in the data. So you can see this thing, no of the circles or asterisk signs are coming beyond the whiskers, either the lower or the upper. Nowhere you can find the whiskers are coming. So maybe that way you can conclude this thing, that there is no outliers available in your data, in your variable IQ. Is it clear to everyone?
Yes, ma'am.
So that
जी
means
मैडम
all, sorry, is it fine?
जी मैडम जी
Yeah.
clear
Okay, fine. So that means all the assumptions we have checked, and we reached at the conclusion that the data is following the assumptions of the one sample t-test, and now you can perform the one sample t-test. So firstly, you need to write down your hypothesis. So can anyone tell me what will be your hypothesis here?
Accept null hypothesis.
Sorry,
Accept the null hypothesis.
I am asking you what will be your null hypothesis. Sorry. Hello.
Ma'am, I have a doubt.
Yes.
Ma'am, like reliability test,
Hmm.
we have to increase, there is a chance to increase the alpha value like that in our normality test. Is there any chance to increase our bell-shaped curve, ma'am? Like in reliability, we have to eliminate the minus values like that in our
Reliability is
normality
a
test.
different concept. Ma'am, for normality, I think there is no such rule. Means you are saying your data is not normally distributed. How you can convert it into the normality? This is what
Yeah,
the question is.
yes, ma'am. Yes, ma'am.
Usually, when
Yes, ma'am.
transformations are there, various types of transformations are available. Using that, you can perform that. But I think sometimes it happens after performing the transformation, also your data is not showing the normality, right? So the other solution is you can go for the non-parametric test.
Okay, ma'am. Like chi-square test,
No,
non-parametric test.
no, not chi-square test. For each and every statistical test, generally we are having the non-parametric test. Say, for example, for independent samples t test, we are having the Mann-Whitney U test. For ANOVA, we are having
Yeah,
Kruskal
you
Wallis
test.
test. Yes, so means we are having the, but according to the need, it is not like every time we will go for the chi-square. No, according, because
Okay,
if
ma'am.
you are having variables of different nature and different type, purpose is different, so we will not always go for the chi-square. You will go for some other non-parametric test.
Okay, ma'am.
Yeah. So I hope it is clear. May I proceed? Can anyone tell me the hypothesis here?
Population mean is equal to sample mean.
Very correct. So we can say there is no significant difference in the mean IQ of population and sample. Fine. Or symbolically, as ma'am said, population mean is equals to sample mean for IQ. Is it okay?
Okay, madam.
Yeah. Now, level of significance we are assuming, suppose it will be 5%. Now, how to perform the t-test? For that, you need to go to the analyze, go to the compare means, then select the one sample t-test. So I'm repeating: analyze, compare means, and one sample t-test. I hope you will have located this.
Yes, ma'am.
Yeah. So if you have located this, now what you need to do? You need to click on the one sample t-test and the box will appear in front of you like this. Now you need to shift your test variable. So we know we are having a single variable available, that is IQ. We are shifting it. We want to test IQ, right? So we are testing IQ. So shifting it to the test variable box. Fine.
Okay, ma'am.
Then you can see at the bottom, we are having a box which is asking you to enter the test value. So what is the test value? I think I explained you in the slide when we are discussing the concept. So what will be the test value?
It is the significance value, ma'am. Level of significance, I
No,
think.
no, 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 sir, no. No. Anyone else? Yes.
What is the known value of mean of the population?
Yeah, it is the hypothesized value or the known value of the mean of the population. Means you need to have the knowledge about your population, then you can get the mean, or if not, you need to assume the mean value of the population, right? So as I can say this thing, we know this thing, this is a fact. I think when I talk about the variable IQ, we know this thing. For a normal people, IQ value should be 100. Only then we can say his or her mental state is stable. If the IQ value is below 100, that means there is some problem, mental retired or type of person it can be, right? Or he or she can be. So generally, we know this thing that the average IQ for the population should be 100. So we are shifting or writing it here 100. Is it clear? Similarly, if you are dealing with some other variable, say for example, we are talking about the BP or something, right? Generally in medical field, you can find this type of terms. BP, it can be cholesterol or something. So we need to know this thing. What is the average BP generally in context to the India? If you are conducting my study in India, or cholesterol, what is the average cholesterol for men or women? Generally, it varies from gender to gender also, right? So you need to accordingly in context you can find from the authentic sources you can get that particular figure. So according to your variable you need to decide upon. Similarly, I think I have given you one more variable in the data sheet, which is the score, right? So might be possible according to my experience, I can say this is the average score in my college for the student. Suppose the data is of my college student, right? So that way I can say this thing that the average mean score in the prestige college is this, right? Clear to everyone?
जी मैडम.
Right.
Yes,
Ma'am.
Yeah. So that way I have written. Yeah. Thank you, everyone. So that way I have written here 100. Now nothing you need to do. Now you can click on the options button. You can find any questions. I hope may I proceed, right? Any questions or something?
बढ़िया 35,000 में कॉर्नर का भी दिया था उसमें नेहा
Neha ma'am.
दो कॉर्नर पे हाँ दो कॉर्नर का दिया था
Neha ma'am.
अच्छा लग रहा था रिंकू नहीं चमका था
अरे भाई बंद कर हमको डर लग रहा है.
Plus, sir, can you mute Neha ma'am?
सब बंद कर दिया.
Neha ma'am, please mute. Yeah, thank you so much. Right. So now when I clicked on the options button, you can find this is the dialog box is coming. There you can see confidence interval percentage is 95%. So we know this thing, there is a relationship between the confidence interval and the level of significance. So if level of significance is 5%, confidence interval will be 95%. Fine. So that means we can say this thing that here the level of significance is 5%, right? But if you want to make changes, that you can do from your keyboard. And if not, you can press on the continue button. So this is all you need to do here, and then you can click on the OK button to get the output. I hope my screen is visible for the output.
Yes, madam.
Yeah. Here you can see. Yeah, fine. Here you can see the first table is for the sample, one sample is statistics. There you can find for IQ, we are having total 40 observations. The mean IQ is 109.45. The standard deviation of the IQ is 5.368 and the standard error of the mean is 0.849. Coming down and looking at the, just a minute, and looking at the one sample t-test table. There you can find that the t-value is 11.133. This is the calculated t-value which is 11.133. Degrees of freedom, as I said, it is n-1. So n is 40, 40 minus 1 is 39. Level of significance is the p-value is coming as 0.000. So if you can see this thing that significant value is 0.000, that means level of significance we have set as 5%. So you can compare the p-value from the 5%. So what you can conclude that the p-value is less than 0.05. So if this is the case, so what I need to do? Should I go with null hypothesis or not?
Not, ma'am.
Yes, we will not go with the null hypothesis. Here we are going to reject, or we do not accept the null hypothesis here, right? As the p-value is less than level of significance. So we can come to the conclusion that we are accepting the null hypothesis and we are making the inferences that there is a significant difference in the mean IQ of population and sample, right? But now, after doing this, if I want to see whether the sample IQ is greater than or population IQ is greater than, so that we can see this is the value of your sample IQ or population IQ. This mean value is what? For sample or for population?
Sample.
This is for sample, very correct. And we have set the value of test as 100, that means this is the population mean value. So you can find the difference is coming as 9.450. 109.45 minus 100 is coming as 9.45, right? So we can say this thing, we are subtracting the sample mean, and then we are subtracting the population mean from the sample mean. So that is why this value is the positive value. So that way we can say this thing, that sample mean is greater than to the population mean. Clear to everyone?
जी madam.
Yes, ma'am.
So if that way you can say this thing, that the sample mean IQ is greater than to the population mean IQ. So this way you can do or perform one sample t-test using the SPSS. So now I'm expecting you people to perform one sample t-test for the score. I hope you people will perform, right?
जी madam.
Yeah. So I think I'll give you the average score here. Suppose you can assume average score is 65 or maybe 60. I think 60 is better. You please go with the 60 as a average score. That is the population mean. And now please perform. So I'm stop sharing. I'm expecting you to perform and you need to tell me the results. So I'm waiting for your answers.
Actually, madam, I have not SPSS software till at now at present, so I can only ta- talk about the testing, how we can evaluate it.
Okay, fine, sir. No issues.
Ma'am, the result is identical to the last variable. This mean is test value we have set to 60 and the sample mean is 68.53.
Okay.
So it's still greater and the p-value is less than 0.05. So you have to again reject the null hypothesis.
Okay, fine. Fine, Ritika ma'am. So that means what we will conclude?
There is a significant difference between the sample value and the population value.
Yes, the
regarding
sample mean score and population mean score. There is a difference in sample mean score and the population mean score. And we can say that sample mean score is greater than population mean score, right?
Yes, ma'am, correct.
Okay, anyone else who has performed it?
Yes, ma'am.
Okay, Sonali ma'am, are you getting also the same results like Ritika ma'am?
Exactly, ma'am.
Fine. And I hope you are able to interpret also properly, right?
Yes, ma'am.
Fine. Okay, anyone else who has performed it?
Yes, ma'am, I have done it.
Yes, sir.
And it's quite similar to the other two participants.
Fine. So means we all are understood this thing, that how to perform one sample t-test using SPSS. But I think no one has checked the assumptions of the one sample t-test for the second variable score. So what I'm expecting you people, means not now, but after the session, if you are getting time before tomorrow's session, if you are getting time, so try to check the assumptions also. Means make it a practice. Usually people are not doing so, but I'll say this thing, according to the journals you need to check wherever you are submitting your work. So in the journals generally, it means from journal to journal, generally these things are varying. So that way you need to check this thing, whether that particular journal is demanding such kind of things or not. If it is, in that case you need to perform these, right? I hope it is clear.
Yes, ma'am.
Yeah. So I think now platform is open for questions and answer. Tomorrow I'll explain you the remaining t-tests. I think only independent samples t-test is mentioned in the brochure or in the flyer shared. But I'll also include the paired samples t-test tomorrow, right?
No polls today, ma'am?
Sorry?
No polls today?
Quiz, if you say I will share, no problem. I can, no problem.
No,
Why?
polls. Poll.
Polls, yeah, that is quiz
Yeah.
and polls, one in the same thing. So, Yogra sir, will you provide me the rights so that I can create the poll? Yeah, sir has already given. Thank you so much, sir.
Can I ask a question?
Yes, yes. Meanwhile, you please ask. Mine. Meanwhile, I'm copying and pasting the
Ma'am, for
question.
this checking the independence of the score variable, we have to again use the descriptive statistics and compare for the Shapiro-Wilk test and
Means-
see the distribution. Or that you're saying to check the assumptions for the score variable as well. The conditions for assumptions for t-test for score variable. So what do we have to do? We have to do the descriptive analysis part again for
No,
that
no.
variable.
Ritika ma'am, if you are talking about checking of the normality, I think there are various methods which are already explained, right?
Yes, ma'am.
So that is totally the decision of the researcher whether you want to go for the descriptives, means on the basis of skewness, kurtosis, mean, median, and mode. You are generally reaching to the conclusion of the normality, or you are going for the standardized test like Shapiro-Wilks or Kolmogorov-Smirnov, or whether you are going for the graphical method. So that is the call of the researcher. I think this is what your question is, right?
Yes, ma'am.
So that is totally depending upon you. If you're good in the graphs and all, you can go for that. There is no problem. But if not, so you can go for the Shapiro-Wilks also, or also apart from that, you can go for the skewness and kurtosis also.
Okay, ma'am. I also, if I'm asking if the assumptions like dependent variable or not, the data is normal or not, it has to be checked for score after the session. The variable.
For?
The variable which we have calculated right now, the second variable score. You've asked us to do it as a homework, right? Checking the assumptions.
Yeah, because ma'am, assumptions are usually for the means assumptions like normality and variance assumptions
Yes,
are
ma'am.
generally
Okay. Got
for
it.
the continuous variable only.
Yes, exactly. Okay.
Right?
Got it. Yes.
Yeah. Yes.
Thank you.
Yeah, thank you so much, Ritika ma'am. I think questions and answers are always good. This will enhance our learning only, right? So if you're asking, it is enhancing my learning also, and I think you're also getting in response your answer. Probably I have justified, right? Okay, moving ahead, putting the second poll.
Ma'am,
Yes.
I don't know. Ma'am, in my dependent variable, okay, in my paper, ma'am, in that is Likert scale, satisfactory, highly satisfied, like that. But here dependent variable is 102, 104 in IQ level. How, ma'am?
Ma'am, just now, give me a second. I'm tapping a question and giving your answer. Give me a minute, ma'am, right?
Okay.
Okay, so I think quiz, sorry, poll one I have already launched. I hope you have seen. I think only 12 votes we have received here. So I'm expecting you. Please go to the poll section, find the poll, read the poll. These polls are for you only. So please read it, understand, and try to give your answers. Poll. Okay. I think motivation is required nowadays. I need to give motivation, and only then the numbers are increasing. So friends, this is for you. Please read it. You answer. This is your own check because I'm not taking the name of any one of you. I will also tell you the answer, right? So question is, if P is 0.056, then whether you will accept or reject the null hypothesis, generally considering level of significance as 5%.
Ma'am, I'm not able to see the poll first question that you posted. I don't know why.
Okay.
Yeah.
Shruti ma'am, you know na from where you need to find this poll?
Yes, ma'am, because I have been given me in the last two polls I have already attempted, but right now today I'm not able to see. That's why I'm wondering that from where to go and see.
Okay, fine.
It's
What
not
about
coming
the?
on the screen,
I think only 18 votes I received. So what
ma'am.
about the
That's
other
why.
thing? Yeah. So what about the remaining one? I hope people are able to find, right? Because 18 votes came only. That means might be possible. Other people are also facing the problem. It is something like.
Yes, ma'am. We also say facing the same problem.
But I don't think so. It should be. It should happen. Okay. Maybe you can leave the meeting and join, ma'am. Maybe. But in that case, again, I need to launch it. If you will leave, probably maybe I don't know. You will get it on because in Google Meet I don't have any idea. If you will leave and again you will join, whether you will be able to see the same poll or not. I think, okay, no problem, ma'am. I am reading the question for you. Question is, you can give me the answers directly once I'm ending the poll, right? Question is, if P is equals to 0.056, P value, significant value is 0.056. So the options are accept the H0, reject the H0, or don't know. These are the options, right? So I'm ending the poll, and then I think you can give the answer. Any one of you.
Ma'am, we accept that zero.
We will accept that zero. Okay, fine. Shilpi ma'am,
Yes, ma'am.
are we accepting the H0?
Ma'am, it is 0.056.
It is
You said.
0.056.
Ma'am, I really confused me.
Accept,
You can note
ma'am.
down. You can note
Accept
down on your
point
paper.
0.5, na? Yes, ma'am. If it is below 0.5, then absolutely we can accept that, ma'am.
Ma'am,
0.5
0.5
now.
is different. Listen carefully.
Yeah,
P
ma'am.
value is 0.056,
Okay.
right? And level of significance is 5%. That is 0.05. Now you please
Ma'am,
compare.
yes, ma'am. Yes, ma'am. In that case, ma'am, certainly not.
We need to accept the null hypothesis, right?
Yes, ma'am.
Yes, ma'am.
Shilpi ma'am, right? Right.
Yes, ma'am.
The correct answer is we will accept the null hypothesis. Out of 20 votes, 16 of you are correct. That your people are saying we will accept the null hypothesis. Fine.
Yes.
I'm launching the second poll now. I have launched the poll number 2. You please read it. So I think for second poll also I received 22 votes. So on the count of 5, I will end the poll. 5, 4, 3, 2, 1. Okay, so fine, I'm ending the poll. Okay, I received total 23 votes for the question number 2. Question was, if mu is greater than sample mean, it is a hypothesis for one-tailed test, two-tailed test, don't know. So Shilpi ma'am, if you have not given answer, you can tell me. Santipriya ma'am, if you have not given answer, you can give me. Then I will tell the answer. I'll repeat, if mu is greater than sample mean.
One-tailed test.
It's one-tailed test. Very correct. So out of 23, 18 of you have said it correctly. It is a one-tailed test. 4 people said two-tailed test and 1 people said no, don't. Right? Launching the third poll. Third poll is available now. Please read it. Okay, so I think on a count of 5, I will end the poll. 1, 2, 3, 4, 5. Poll ended. Received 28 votes. Question was, normality can be checked using histogram, box plot, both of the above, none of the mentioned. Shanti Priya ma'am,
Ma'am,
do I need to repeat?
both the above, ma'am.
Both of the
And
above.
QQ plots also, ma'am.
Okay. Shilpi ma'am, you have answered?
Yes, ma'am. Both. Yes, ma'am. Both the above.
Fine.
By box plot as well as the histo also.
Very correct. Very correct. So I think out of 28 votes, 19 of you said correctly. We can use both the methods, histogram and box plot, for checking the normality of my variable, right? So it's good. So I think this is a way of understanding that how have transferred from here to there. I hope this will help you people. I think for the today I'm keeping only till 3 polls. Yesterday I tried to make some more polls and maybe 5 or 6, because tomorrow I'm going to cover 2 of the tests, that is independent samples or and the paired samples t-test, right? Fine. So okay, fine. This is all from my side for the day.
Thank you, ma'am. Thank you so much, ma'am.
Thank you. Thank you, everyone. So now it's the pick time. If you can switch on your cameras. Thank you, everyone.
Thank you.
Thank you. So anyone? Yes.
Thank you,
Sonali,
ma'am.
Vivek sir. Wow, that's great. It's great to see so many of you, that you people are active till the last what I can say moment of this particular. Thank you. I think many of you are typing. Just a minute, I need to close this. Otherwise, I cannot capture the faces. Please switch on your cameras. Yes. It's very good to see the beauty faces at the end of the day when we are very tired. Thank, thank you for your active participation, everyone. It is literally a motivation for a person who is delivering through the online platforms. Thank you.
Thank you very much, ma'am.
Thank you.
Thank you.
Thank you, ma'am. Take care, ma'am. Bye bye.
Thank you. Bye bye. Thank you, everyone. So, Yoga sir, we are done for the day. Thank you. Thank you.